Number 27, 48x minus 64y equals 48y plus 24, and r times y equals 1/8 minus 12x. In the given system of equations, r is a constant. If the system has no solution, what is the value of r? If we're speaking in graphical terms, when we have a system of equations, it can be two lines, it can be, a parabola and a line, any of those combinations, there's tons of them. And we're always looking for the place where these, the graphs of these equations intersect. And there are ways to solve systems of equations, on paper. But if we're visualizing them, that's what we're thinking of is where do they cross in the xy plane? Now, if we look at these two equations, they both just involve x's and y's. There's no x squared, x cubed, square root of x, random ruler. There's none of those things going on. So these are just lines. Each of these is a line. Now, if I have in my system of equations two lines, there's three options for what can happen. They may intersect, in which case they have one solution. They may overlap, be right on top of each other, in which case there are infinite solutions. Or they may be parallel to each other. And in that case, there are no solutions. So for both this one and this one, the way you can tell that it's one of these two is that they will have the same slope. If it's this one over here, it has the same slope and also the same y-intercept. And over here, it will have the same slope but different y-intercepts. So since we're talking about no solution, we know we are dealing with this one over here. So if we look at them graphically, we want to see these parallel lines. If we're looking at them on paper, we want to see the same slope, different y-intercept. Now, can we solve this through graphing? We have this unknown constant. If there is a known constant, if this was a number, then yes, we could solve this graphically. We could see what's going on. But that's the kind of problem where you're saying, where do these lines intersect? What is their solution? Graphing is often an option. This one, not so much, because we have this unknown, this r. And trust me, you don't want to just graph these and just start plugging numbers in for r. Don't do that. In this particular one, you're going to be sitting here a while, I suspect, before you find the right answer. Now, there are two different ways we can look at this problem. A lot of times, when we have these sort of funky puzzle problem, let's use a bunch of different things you've learned over the years in one, which is usually in these higher numbers when we get up to the 20 to 27, we get more unusual problems that you may not have seen similar examples in your math book before. That just happens. This particular one, there's two ways you can solve it. I'm going to show you the more, let's say, traditional way first, and then I'll show you a little shortcut of sorts that I saw that worked for this particular problem. Okay, as I mentioned, first, the traditional way first. As I mentioned just a few seconds ago, we're looking for them to have the same slope. Now, the easiest way to kind of compare these two and get them to have the same slope is if we put them both into y equals mx plus b format. When we do that, when we have y by itself and just a single y and everything else on the right, the m, the coefficient that's by the x, will be our slope, and the b there will be our y-intercept. That's the number that's all by itself, all by its little lonesome. So let's put both of these into y equals, and then everything else on the right, format, and we'll have our slopes. So our first one, our top equation, 48x minus 64y equals 48y plus 24. We want y by itself, everything on the right. So first, and it really doesn't matter where you start, just as long as you get to that point. I'm going to move that positive 48x by subtracting 48x from both sides. That gets rid of it on the left. Then I have negative 64y equals negative 48x plus 48y plus 24. And then next step, I'm going to get this y, the set of y's, these 48 y's, I'm going to move them over to the left. Since we have here adding 48y, I'm going to do the opposite. I'm going to subtract 48y, and that will effectively move it to the left and get rid of it on the right. So on the left, negative 64y plus a negative 48y is negative 112y. And then on the right, I have negative 48x plus 24. Now I'm going to divide everything by this negative 112. So now I have just y by itself, and it's equal to, and those negatives cancel out, and I will simplify this in a second, 48 112ths x plus, actually let's change that to minus because it's, instead of plus a negative, let's just make it cleaner. So minus 24 over 112. I'm not going to worry about simplifying the 24 over 112 because it doesn't matter for our problem, and I'm not going to waste my time on that on the SAT. I am going to see about simplifying this one because I think that's going to help me in a minute. I like having more simple fractions. So let's see if we can do that quickly. Now, even if you don't see the greatest common factor that's in here, that's fine. What you can do is you can go, they're both even. And you can just start with that and just start working away at it with them being both even. You might look at it and go, I know 4 goes into 100 and then 4 goes into 12, so 4 must go into 112. And I know 4 goes into 48, so I'll start with that. I'll take 4 out. It really doesn't matter where you start as long as you're like whittling it down. You also can use factor trees. Videos on that will be below if you want to find out how to use factor trees to find greatest common factors. Totally viable as well. All right, but I'm going to just divide by 4. When I do that, 48 divided by 4 is 12. And here, 112, divided by 4 is 28. Like, they're still both even, and also 4 goes into both of those. Okay, so I can go a little bit further. 4 goes into 12 3 times, and it goes into 28 7 times. I think I've got my simplest form, 3/7. So this is the same as y equals 3/7 x minus 24 over 112. All right, so now I know that my slope for that first line is 3/7 x. So I'm going to write that up here. My slope for that first line is 3/7. Okay, so now we're going to need the space, so this is all got to go. We're going to move on to our second equation. And that is r times y equals 1/8 minus 12x. And I'm going to reorder those so it looks more like my y equals mx plus b. ry equals a negative 12x plus 1/8. Now to get y by itself, it's currently being multiplied by r, our unknown constant. So I'm going to divide everything by r. And this one right here, when you divide a fraction by something like 1/8 divided by r, dividing by r is the same as multiplying by 1 over r. Just like, dividing by 2 is the same as multiplying by 1/2. Same principle at work. So 1/8 times 1 over r is how you would do that. Okay, so back to our equation here. R times y, and then I divide it by r. So on the left, I just have y. My next one, I have negative 12 over r x plus, as I said, it's 1 over 8 times 1r, so 1 over 8r. But again, also, this doesn't matter. Y-intercept doesn't matter. I don't care about it. All I care about is my slope. And I know now that the slope of my second line, its slope is negative 12 over r. Now, I need these slopes to be the same for this system of equations to have no solution. They need to be the same. They need to be equal. So I'm going to set them equal to each other and then figure out what I could put in for r to make this a true statement. So 3 over 7 equals negative 12 times r. And there's 2 ways that you can do this. I'm going to show them to you next to each other. Okay, one thing you can do, and it always works, is you can cross multiply. So I get 3 times r is 3r, and 7 times negative 12 is negative 84. Then since it's 3 times r, I want to undo that, so I will divide by 3 on both sides, and I get that r is equal to negative 28. That always works no matter what numbers you have in this proportion. Now my second way over here is a shortcut of sorts. It works if you can multiply, say, one of these numbers to get to the other numerator, or if I could multiply a denominator to get to the other denominator. That's not always possible. You know, it could have been something like 3/7 equals 5 over r. There's no way to multiply 3 by an integer to get to 5. 5 is not a multiple of 3. This particular case, however, we can use that shortcut and say 3 times what equals negative 12? Negative 4. So then I would multiply the same thing on the bottom. 7 times negative 4 would equal r. So r is 7 times negative 4, or negative 28. That's another way you can do it in this particular case, but like I said, sometimes the numerator is not a multiple of the other numerator, so you can't do that. Oh, times negative 4 times negative 4. This way will always work, regardless of whether that multiple thing is true or not. So, okay, so r is negative 28. That is my answer, and I'm going to write it over here. And now I'm going to show you the other way that you could have found this out, which works in this particular problem. And I want to always differentiate those two methods, because there are ways that will work for a particular problem because of the parameters of that problem. But the way I just showed you, where we find the slope of each of these by putting them into y equals mx plus b and then setting those slopes equal to each other, would always work regardless of any of the quirks of how these equations relate to each other. And there is a quirk here that you can exploit in this particular instance. And if it's one of those things where if you see these exploits, you see these little quirks, these little shortcuts, it can save you time. But if you don't see them, it's okay. You still have the way I showed you before will absolutely work. So here is the quirk that sometimes happens. It's if when you're working this, you realize that the equations are starting to look like each other. And if you can get them to look like each other, if there's a way you can manipulate things so that they look like each other, you'll have your shortcut. Let me show you what I mean. 48x minus 64y equals 48y plus 24. If I start moving things over like I was doing before, I'm starting out that same way because that's my method. I'm like, I know, I'll put them both into y equals mx plus b. I'll set the slopes up, equal to each other. Okay, so let's start that process. It's going to start out exactly the same. Where I moved the x over to the right by subtracting 48x from both sides. It's like, okay, so now I've got negative 64y equals, and I'm just going to write, okay, so 48y plus 24, and then I subtracted that 48x, okay. And then I want to get the y's over to the left, so I'm going to subtract that 48y, so it'll cancel on the right. I have to do that to both sides. Then, like before, I get negative 112y equals, the y's cancel out, 24 minus 48x. And here's when I look at it and go, this is looking kind of similar to that. Is there something I could do where I could get those x's to be exactly the same? Is there anything I could do to this whole equation to get the x's in these two equations to be the same? Because if I did that, if I could get the x's to be the same, because that's where the slope is, then all I would have to do is look at what coefficient is here by y, and it would be the r, because they would have to match. They'd have to. The coefficients of the x and the coefficients of the y. If the coefficients of the x match, then the coefficients of the y would need to match too for these to be parallel. Because when you go that next step further and you start solving for the slope, I would be dividing by this number. So it would be this coefficient divided by this number, And over here, it's going to be this coefficient divided by this number, and they would have to be the same. So I'd have to be dividing by the same thing if the coefficients of the x were the same. Okay, this may be a little tricky to understand. I get it. I hope I'm explaining it well. But yeah, like I said, previous way, always going to work. Okay, so let's look at this. What can I do to get from negative 48 to negative 12? And we always want to think about like multiplying and dividing because that's something that will affect everything. Whereas if I add or subtract, that only affects the x. We want to affect everything. So if I divide negative 48 by 4, I will get to negative 12. So let's do that. Let's divide everything over here by 4. Because then it all stays even. Everything's good. What do I get on the left? Negative 112 divided by 4 is negative 28y equals 6 minus 12x. And there we go. They are set up to match. The 6 and the 1/8 don't match, and I wouldn't expect them to, because this number that's by itself is what's going to become, or what represents the y-intercept once I get it into y equals mx plus b form. So they should be different because they can't have the same y-intercept. But now I've got my negative 12x, negative 12x. I've got a coefficient by a y. That one has a coefficient by a y. They would have to match so that in the next step, when I divide by that coefficient, I get the same slope for both of them. Because I'm going to divide, down here on the bottom, I'm going to divide everything by negative 28 to get y equals. So it's going to be negative 12 divided by negative 28, and that's going to be my slope. And up here, on the left up here, same thing. To get the slope, I've got r times y, so I'm going to divide everything by r. So it'll be negative 12 divided by r, and they have to match. So that r, it must be this coefficient here. It must be negative 28. And so if you have that sort of epiphany as you're working through this, when you get to this point, it does save you time. It does save you steps, because instead of dividing by negative 112, simplifying that fraction, then converting this one, then setting those slopes equal to each other, solving for r, all you do is one more step of dividing everything by 4, and then your answer's there, ta-da, right in front of you. Those kind of little shortcuts and things, they get easier to see the more you practice, the more you do with the SAT problems, especially these end of the road, end of the section problems that are a little more tricky, that are a little more multi-step and puzzles. Where they're like, pull together everything you have learned into one problem and show us what you know. It's that kind of thing. Whereas up to this point in the sections and the modules, it tends to be more like, here are problems you've seen in school. And then you get to these at the end, and it's like, hey, have fun. The more of these you practice, the more of these you do, the more likely you are to see these kind of, these little tricks that can cut time out and give you a little more time to work on other problems, to check your work, things like that. But said it before, and I'm going to say it again, it doesn't mean you're going to get it wrong. If you don't see their little shortcuts, you still have the more traditional methods to rely on. They will get you the answer. And you've reached the end. Congratulations. Hey guys, head over to my new site, mathwithalyssa.com, to get your free, yes, free 10-video course of SAT tips and tricks. It covers things like how to make a study plan that's perfect for you, how to pace yourself during the test to get maximum points, and so much more. I'm super excited to get this out to you guys, and a lot more SAT prep help is coming for you in the weeks ahead. Again, that is mathwithalyssa.com. And if you liked the video you just watched, please let YouTube know. Comment, like, share, subscribe. You know the drill. Thank you so much for watching. Hope you have a great day. See you later. Bye.